So graphing by using the vertex formula to find the vertex. So in the previous examples we had integer coefficients in our quadratic expressions, and we had each vertex occur at integer values. As we start to look at real-world data, the constants a, b, and c for the best fitting quadratic function will not be integers. So from the previous page of notes, we know we can use two symmetric points. Okay, so two symmetric points are points that are directly across from each other. So they have different inputs but the same output. The easiest point to find for a given function is its y-intercept. So to find it, we just simply plug in an x value of 0. If we could then find the point symmetric to the y-intercept, we would have two symmetric points to use what we did on the previous page where we found the average of those two to start to help us find that vertex. So for a given function, it says to answer the following. So we have f of x equals 3x squared minus 15x plus 7. Again, we should notice that this is quadratic. We have our necessary x squared term, and again, our optional x and constant terms. So first we're asked to find the y-intercept. So again, the y-intercept is the output when the input is 0. So we want the y-coordinate when x is 0. So if we take f of 0, we're going to get 3 times 0 squared minus 15 times 0 plus 7. And again, eventually you should just be able to eyeball and know that that's going to be 7 because all of the terms with the variables will become 0. Okay, so this puts our y-intercept at the point 0, 7. Okay, for an input of 0, we get an output of 7. So now we want to find the coordinates of the point that is symmetric to the y-intercept. Okay, so symmetric has same output, and the y-intercept we just got was 0, 7. Okay, so the same output would be 7. So basically we're being asked what other point on the graph has an output of 7. So the output is 7, so we're going to put 7 for our output, and we're trying to find the input values of x that give us an output of 7. So we want to solve this equation for x. Okay, we want to find the values of x that make this equation true. Okay, well, again, it's quadratic, so our first step so that we can use the zero factor property is to get all the terms on one side. So this is really a positive 7. So we're going to subtract 7 from both sides, and we'll get 0 equals 3x squared minus 15x. Okay, so again, a quadratic equation, our goal is to get it 0 equal and then a factored form on the other side. So these two terms each have a 3 and they each have an x in common. So if we factor out 3x, we have x, so 3x times x gives us back our 3x squared. And here we're going to get minus 5. So 3x times our negative 5, we get negative 15x. Okay, so now we have 0 equals the product of two factors. So we can use the zero factor property. And at least one of these, if two numbers being multiplied together give us 0, at least one of these numbers has to be 0. So either 3x equals 0 or x minus 5 equals 0. And this gives us x equals 5, and this gives us x equals 0. Okay, so this one we already knew. Okay, so this tells us that for an input of 0, we would have got an output. So this gives us one of our points, which we already had. But this gives us the other one. For an input of 5, we also get an output of 7. Okay, so here are our two symmetric points. So now we have two symmetric points. Okay, they have the same height, okay, at 7, and we're going to use them to find the coordinates of the vertex. So again, if we think about plotting, we would have a point at 0, 7, that was our y-intercept, and then we got another point over here at 5, 7. Again, our axis of symmetry cuts down right between those, and the vertex has to be on this axis of symmetry someplace. Okay, well, midway between 0 and 5, we have 2.5. So x has to be 2.5. Okay, so again, we've got, if we did our axis here, we had one at 0. This is our x-axis. And we had another point over here at 5. And so to get this x-coordinate, we use the average x value. So it was 5 plus 0 over 2, which gave us our 2.5. And then to get the y-coordinate, we need to know the output when the input is 2.5. So we're going to evaluate the function for an input of 2.5. So we're going to get 3 times the quantity 2.5 squared. Oops. And then minus 15 times the quantity 2.5 plus 7. And if we evaluate this, we get negative 11.75. Okay, so for this particular problem, our vertex is at 2.5 and negative 11.75. Okay, so this leads us to something called the vertex formula. So we can find two symmetric points like we did here. So we can find our y-intercept and find the point that was symmetric to the y-intercept and find, our x-coordinate midway between those. Okay, but we can also start to notice some patterns as to where those numbers came from. Okay, so if we're looking at where this 5 came from, that we got here, and it showed up again here in our formula, okay, that number we got up here when we factored, we took this 15 and we divided it by 3, and again, then we moved it to the other side, it changed the sign. So it was really the opposite of this coefficient over this coefficient. So if we take the opposite of negative 15, we would get 15. Divide by 3 gives us 5. But then we added 0, which didn't add anything. And then to get the midpoint, we divided by 2. Okay. So in recognizing that pattern, so we had the opposite of B, and we divided by A. That's where our 5 came from. But then we added 0, which didn't add anything. But then we then divided by 2. So it also puts another 2 down here in our denominator as well. So given a quadratic equation with its coefficients a, b, and c, we can get the coordinate for that vertex by taking the opposite of b over 2a. And then to get the output, we're just going to put that number, whatever it comes out to be, through our function. Okay, so for this one, if we use the vertex formula, we have the coefficient on x squared is 3, coefficient on x is negative 15, and our constant term is a positive 7. So if we evaluate the opposite of b over 2a, so we get the opposite of negative 15, 2 times 3. So the opposite of negative 15 is 15, and 2 times 3 gives us 6. And if we take 15 divided by 6, we get 2.5, exactly what we got up above. And then to get the output, we would put 2.5 as an input to see what our output was in the function. And if we do that, again, we're going to get negative 11.75. So this gives us another way of finding that vertex for the graph of our quadratic function.